All right, in this lesson, we are talking about something called literal equations, which we'll define in a bit. We're going to start with a warm-up about solving these one-variable equations. And so to solve a one-variable equation, I like to draw a line where the equal sign is, and then identify my variable. And so my variable is x. There's only one of him, so we just need to isolate him using inverse operations. We need to get rid of the 12 first because it's furthest from the variable. Always get rid of the number that's not attached to your variable first. And then now we can divide by the 3 since we have multiplication happening. And so x equals 12. In this next example, we have parentheses, so we need to distribute the 3 halves first. Remember, you are multiplying by the top number, dividing by the bottom. And so if you want, you can divide first. Divide by 2, we get 2h plus 3. And then when we distribute the 3, we get 6h plus 9 equals the 9. Now we can subtract the 9 from both sides. And we get 0 on the right-hand side. And then divide by 6, and we get h equals 0. Don't be afraid if you get 0. 0 is a number just like anything else. It's not a special case. It's not a no solution. 0 is a number. Okay, so now we're going to solve literal equations, and it's just an equation that has more than one variable. And so you have to really pay attention to which variable you're solving for. In the warm-up, it was clear that we were solving for x, we were solving for h. So to solve the equation, we isolate the variable. The same thing happens with literal equations, only you need to pay attention to which letter you're trying to isolate. So in number 1, I see an x and a y, and we are solving for x. Okay, and so these look harder, but they're actually a little bit easier since you're working with letters. You don't have to number crunch or simplify as much. And so to isolate this x, we get rid of this 6 using the inverse operation. It's minus 6, so we need to add 6. And so on the left, I just have x. On the right, I have y plus 6. Those are not like terms, so we have to leave them separate. And so our final answer is just x equals y plus 6, and we're done. That's the best we can do since we have another variable. Okay, on number 2, we are solving for a. And so in this case, a is being multiplied by c. And so to get rid of the c, we divide by c. We still do inverse operations just as if that was a 2. And so if it helps, replace these extra letters with a number and ask yourself, what would you do? And so now I have g divided by c equals a, and so we're done. I always write the variable we're solving for on the left for my final answer. A equals g divided by c. Number 3, we're solving for x. And so we just need to get rid of the 4. It's division by 4, so we just need to multiply both sides by 4. And so x equals y times 4, which we write as 4y. On number 4, we are solving for n. Okay, and so it says minus n, so I'm going to go ahead and write the 1 next to it. So as we isolate it, we know we'll get rid of that negative 1. Okay, and so our first step is always take care of what's not attached to your variable. So cover up the variable, and the expression that's not attached is the m. So we need to get rid of that m first. It's positive, so we need to subtract it from both sides. And that leaves me with just a negative 1n on the left and a p minus m on the right. We can't put those together, so we just write them as is. It says p, and then we're subtracting m. And then in our next step, we need to get rid of this negative 1. It's being multiplied, so we have to divide it as we try to isolate n. And so when you divide by -1, it switches the signs of whatever is above it. And so we can write our final answer with a negative p and a positive m, or you can switch the order and write m minus p. Any of these would be fine on a multiple choice test. Just recognize that p is negative, m is positive, and you'll get the answer right. Okay, number 5, we're solving for a. Just like the previous example, I'm going to put the 1. And so to isolate a, we need to get rid of this 2x. Don't separate the 2 from the x. We don't want to isolate x. We're isolating a. We just need this whole term to go away. Since it was positive, we subtract it away. We just need it to move to the other side. Okay, and then our last step in isolating a is to divide by the -1. And so just like the previous example, it flips the signs of the terms above it, and then we can even switch the order and put the 2x before the m. All of these are equivalent. Okay, here we are solving for r. So I'm going to put the 1. And so we need this whole x over 4 term to go away. It's always tempting to multiply both sides by 4 because we're always in the habit of isolating x. We are solving for r. We do not care about isolating x. We only care about isolating r. So we need that whole expression to go away. Don't separate them, take them away. So it leaves me with -1r on the left, and then we had a h, and then we have the minus x over 4. Can't put them together, can't simplify them. We just have to write them both. And then here our last step is to divide everything by -1, which we know just flips the signs. So -h plus x over 4, and then we can switch the order. X over 4 minus h. Okay, this one's hard. Here we're solving for x, and x is in the bottom of a fraction. So we don't usually move the variable we're trying to isolate, but if it's ever trapped in the bottom of a fraction, we have to. Okay, and so the first step here is we want to get x out of the denominator. And so since this means division by x, we can multiply by x both sides to keep it balanced. It's only legal if you do it to both sides. And then the x's would cancel on the left, leaving me with just that m. And then on the right, I have the p times x. So we're still trying to isolate x, and our first step is to get him out of the denominator. Now that he's out of the denominator, we just need to divide both sides by p, and we will have isolated x. And so x equals m divided by p would be our final answer. Okay, this next one, we are solving for a. And so our first step is to get rid of what's not attached to a. And so in this case, that's b. And so I have g plus b on the left and c times a. You can put your multiplication dot if that helps. And then still trying to isolate a, we need to divide by c. And make sure you divide the entire side, not just the g, not just the b. The entire left-hand side gets divided by c. And so g plus b all over c equals a. Write the a on the left. And we have our final answer. Okay, these last two examples are going to be very important in a later unit, and it's solving for y in terms of x. Okay, so here we have y, and so our first step is to move this x term to the other side. Get rid of it. Don't separate the 3 and the x, just take them all away. So that leaves me with 4y equals, and then you could put these in either order. I'm going to do 18 minus 3x. And then divide everything by 4, the whole side by 4. And so y equals 18 minus 3x all over 4. In a later unit, we're going to want to clean this up quite a bit. And one way we clean this up is to write each term in the numerator over that 4. And then we usually put the x term first. So I'm going to put the negative 3/4 x, which is the same thing as 3x over 4. The x doesn't have to be in the numerator. He can be outside the fraction. And then we would put the plus 18/4. This is called slope-intercept form. And that's going to be our ideal answer. For the sake of this lesson, this would also be correct. Okay, in this one, we are solving for x. Okay, and so our first step is to move the y term. Sometimes I say move the y term. It's the same as getting rid of the y term on the left-hand side. And I'm going to go ahead and put the y term followed by the positive 1. And then lastly, we're ready to divide by -2 because we're trying to isolate x. And you can leave your answer just like that. It's not standard to leave a negative in the denominator, so sometimes we'll put it completely outside the fraction. You have to be careful when moving it to the numerator. If you do want to move it to the numerator, you would distribute it to both terms in the numerator. And so all of these are equivalent answers. Okay, and so now let's look at some applications of when we would use a literal equation. One example is in geometry with the volume formula. Another is with Celsius and Fahrenheit, converting between Celsius and Fahrenheit. I don't know how to spell Fahrenheit, so I'm just going to leave that off. And then this is circumference of a circle, I believe. And then this is perimeter. Okay, and so here it says the volume of a square pyramid is given by this fancy equation where V is the volume, S is the side length of the square, and H is the vertical height of the pyramid. Solve for H. Okay, and so I'm going to recopy the equation. And we are solving for H. Okay, and so one thing we can do right off the bat is get rid of the 1/3 by multiplying both sides by 3. 3 times 1/3 would cancel. And so that would leave me with the equation 3v equals s squared h. Okay, and so now remember the goal is to isolate h. And so we need that s squared, which is being multiplied by h, to go away. And we do that by dividing. Okay, and so that gives me 3v over s squared equals h. And so we can write our final answer as h equals 3v over s squared. It was a capital V, so try to preserve what notation they're using. Okay, here for the Celsius and Fahrenheit formula, we're solving for F. And so usually I would tell you to distribute the 5/9. But another way, just like I multiplied by 3, which is technically 3 over 1, we can multiply by the reciprocal, 9 over 5. And that would also cancel this 5/9. You can cancel multiplying by a fraction by multiplying by the reciprocal. And so instead of distributing that to the parentheses, since there's nothing else going on outside, we can go ahead and get rid of the 5/9 rather than distributing it. If there was like a plus something out here, you wouldn't be able to do that. You'd still have to subtract that, whatever's being added first. Okay, so we have 9/5 C equals the F minus 32. And then next we can add the 32. And so 9/5 C plus 32 equals F. And so we can write our final answer with F equals 9/5 C plus 32. And so this would be valuable if they're giving us the temperature in Celsius. We can just plug it in right here and then get the Fahrenheit formula or the Fahrenheit value. All right, and then here we are solving for R. Currently, he's being multiplied by 2 and pi, and so we can divide those off right off the bat at the same time. One-step equation. So R equals circumference over 2 pi. Write the R on the left, and you're done. Okay, here's our perimeter formula, and we are solving for L, the length. Make sure when you do your L's, they don't look like ones. Here you can see it looks like a 1. And so I do cursive L's, which is a loop. And so P, or you could also do capital L's if that's more familiar for you. P equals 2L plus 2W. And so we are solving for L. I don't usually like changing their letters, but in this case I will. Not changing the letters, but changing the case. And so our first step is we need to get rid of what's not attached to the variable first, which in this case is 2W. Don't separate them, just make that whole term go away. And so now I have P minus 2W on the left, can't combine those. And then lastly, we're dividing everything by 2. And so L equals P minus 2W over 2. And so that's one way to write it. I do want to show you an equivalent form because sometimes they simplify it. And so just like in a previous example, we can write each term in the numerator over that 2. And then when you have one fraction right here with the same number on top and bottom, they cancel. And so an equivalent way to write this would just have the W without the 2's because they would cancel, but it's still under the P. And so just be careful if you don't see your answer as one of the choices, see if you can simplify it a little bit.